Hi guys! In this video, I'm going to discuss on quadratic function derived from zeros of the function. Using the quadratic formula, x equals negative b plus or minus square root of b squared minus 4ac over 2a, we can let the first zero, x of 1, equals negative b plus square root of b squared minus 4ac over 2a, and the second zero, x of 2, equals negative b minus square root of b squared minus 4ac over 2a. Now we can have the sum of the zeros of the quadratic function as x of 1 plus x of 2. That will be x of 1 is negative b plus square root of b squared minus 4ac over 2a plus x of 2 negative b minus square root of b squared minus 4ac over 2a. Then solving this one, we can have negative b minus b. That will be negative 2b. Then square root of b squared minus 4ac minus square root of b squared minus 4ac. That will be 0. Then 2a, the denominator here, you will just copy it. This is over 2a. Then simplifying this one, we can have negative b over a. So this is the sum of the zeros of the quadratic function. Now if we're going to have the product, x of 1 times x of 2, we can have negative b plus square root of b squared minus 4ac over 2a times negative b minus square root of b squared minus 4ac over 2a. Then in here, in the numerator, this is just product of sum and difference of two terms. So we can just apply the special product. We can have here square of the first term, negative b squared, minus the square of the second term, square root of b squared minus 4ac squared over 2a times 2a, that will be 2a squared. Then this will be equal to negative b squared is b squared, then minus square root of b squared minus 4ac squared is b squared minus 4ac over 2a squared is 4a squared. Then simplifying this one, this is just equal to b squared minus b squared plus 4ac over 4a squared. Then this will be equal to b squared minus b squared is 0, so we're going to have here 4ac over 4a squared. Then 4ac divided by 4a squared, the result here will be c over a. So this is now your product of the zeros, x of 1 and x of 2. Now if you're going to have the standard form of quadratic function, y equals ax squared plus bx plus c, if we're going to make the numerical coefficient of the leading term equivalent to 1, so dividing the equation by a, so we can have here ax squared plus bx plus c divided by a is x squared, then plus b over ax, then plus c over a. The sum of the zeros, x of 1 plus x of 2 equals negative b over a, and the product is x sub 1 times x sub 2 is c over a. We can just have that one as in here. The product of the two zeros will be a constant term here. Then the sum of the two will be the negative of the numerical coefficient of x in your quadratic function. So we're going to use this one in deriving quadratic function from zeros of the given function. Example number 1, find a quadratic function with 3 halves and negative 1 as its zeros. So we're going to find the sum first. Sum will be x sub 1 plus x sub 2. It will be equal to 3 halves plus negative 1. Now in here we can express negative 1 as negative 2 over 2. So we can have this one as 3 halves plus negative 2 over 2. So 3 minus 2, that will be 1. Then we'll just copy the denominator 2. So the sum will be 1 half. Then if we're going to have their product, we can have x sub 1 times x sub 2. So 3 halves times negative 1. So that will be negative 3 over 2. Now, we'll just find the negative of this sum here. So we're going to have negative of 1 half, and that will be the numerical coefficient of x, and this is the constant term. So your required function here will be y equals x squared. The negative of this one is negative 1 half x. Then the constant term minus 3 halves c over a. And if the integer coefficient is required, what we're going to do is we'll just multiply the equation by 2. So you can just have your answer as y equals x squared times 2 is 2x squared. The negative 1 half x times 2 is negative 1. So we're going to have here negative x. Then negative 3 over 2 times 2, that will be negative 3. So we can have y equals x squared minus 1 half x minus 3 halves, or y equals 2x squared minus x minus 3. Example number 2. Find a quadratic function whose zeros are 2 plus square root of 3 and 2 minus square root of 3. So sum will be x sub 1 plus x sub 2. That will be 2 plus square root of 3 plus 2 minus square root of 3. So 2 plus 2 here is 4. Then square root of 3 minus square root of 3 is 0. So the sum here will be 4. Then for the product, we're going to have here x sub 1 times x sub 2. That will be equal to 2 plus square root of 3 times 2 minus square root of 3. Again, this is an example of product of sum and difference of two terms. So we'll just apply the procedure in having that special product. So the procedure will be, you're going to square the first term. So 2 squared will be 4. Then minus the square of the second term. So square root of 3 squared will be 3. So 4 minus 3. So 4 minus 3, that will be equal to 1. So we're going to take the negative of this one. This will be the numerical coefficient of x. And this one will be the constant term. So the required function will be y equals x squared plus the negative of this one, negative 4x, then plus 1. and this is just same as y equals x squared minus 4x plus 1. Example number 3. Find a quadratic function whose zeros are 2/3 and negative 1/3. So we're going to have the sum. X sub 1 plus x sub 2 equals 2/3 plus negative 1/3. So 2 plus negative 1, that will be 1. Then copy the denominator 3. Then for the product, we're going to have here x sub 1 times x sub 2 will be equal to 2/3 times negative 1/3. So 2 times negative 1 is negative 2, and 3 times 3 is 9. So that is negative 2 over 9. So the required function here will be y equals x squared. Then the negative of this one is negative 1/3. So we're going to have negative 1/3 x, then minus 2 over 9. And if we're going to have the integral coefficients, we can have this one as y equals multiplying the function here with 9. So we can have 9x squared. Then negative 1/3 x times 9, that will be negative 9 over 3. That will be negative 3x. Then negative 2 over 9 times 9, that will be negative 2. So we can have your answer as this one or this one. I hope this video helped you. If you have questions about the topic, please comment down below, and see you next time.